In this video, we'll be graphing hyperbolas. Our technique for graphing hyperbolas, we want to start by identifying the center. That's going to be our HK. Remember that H is always with X and K is always with Y. Then we want to use dashed lines to draw the rectangle centered around the center with sides of plus or minus A and plus or minus B. Then we'll draw in the diagonals of this rectangle and extend them to obtain the asymptotes of our hyperbola. Then we'll draw the two branches of the hyperbola in by starting at each vertex and approaching the asymptotes. Let's graph x squared over 1 minus y squared over 4 equals 1. We'll state the center, the vertices, the foci, and the asymptote equations. The first thing I notice about this hyperbola is that the x is first. So that tells me that the hyperbola branches are going to open in the x direction. So this is going to be a horizontal hyperbola. Next, we want to identify the center. Since we don't see any parentheses, we know that the center is the origin. And now we want to create this rectangle that was described in the steps. This is a very similar move in my mind to what we do when creating the ellipse. We're going to plot our center at the origin. Now, the number under the x, we're going to go the square root of that number in the x direction from the center. So we'll go 1 to the left and 1 to the right. And then we'll go the square root of the number under the y from the center in the y direction. So the square root of 4 is 2. I'm going to go 2 up and 2 down. When we were creating an ellipse, we then drew an oval around those 4 points. But here with the hyperbola, what we're going to do is create a rectangle instead. And I'm using dashed lines just because it's not actually part of the graph, and that's usually the notation we use to indicate that something's more of a guideline than an actual part of the graph. From here, we're going to extend the diagonals of this rectangle, and that's going to give us the asymptotes for our hyperbola. So to do a good job extending them, I kind of look at what the slope is. Notice in the rectangle, I'm going down to the right one here. So I kind of keep that in mind as I'm extending these lines. Now that we have our asymptote, we're ready to draw in the branches of our hyperbola. We already stated that it's going to be opening in the x directions. It's going to hit, these are our vertices here, this is where it's going to hit on the rectangle, and then we just have the branches tend towards the asymptotes. And here we have our hyperbola in blue. Now we need to go back and answer the questions that were asked in the directions. They wanted the vertices, the foci, and the asymptotes. So the vertices, that's where our hyperbola is hitting the box, our rectangle. So that's happening at -1, 0, and 1, 0. Next, we need to find the foci. Remember that with the hyperbola, c squared is equal to a squared plus b squared. When it's a minus in the equation, it's a plus in the formula for c squared. So c squared is going to be equal to 1 plus 4. We get c to be the square root of 5. The foci are going to lie inside the branches of the hyperbola. So we are going to be adding this c value to the x coordinate of our center because it's opening in the x direction, so we're always going to add it to the x. We get our foci to be plus or minus the square root of 5, comma 0. Right, because we had 0 plus or minus square root of 5, but we don't need to write that 0 for the x coordinate. The last thing we need to do is identify the asymptotes. And there's two of them. So if we zoom in, looking at the first one, notice that it has a y-intercept of the origin and a slope of positive 2. Oh, we can just write that right into our y equals mx plus b, and we get our first equation to be y equals positive 2x plus 0. We don't need the plus 0 there. And then our other asymptote also has a y-intercept of the origin, but this time has a slope of negative 2. So we'll plug those two things into y equals mx plus b. We get our second asymptote to be y equals negative 2x. Let's try another one. This time our center will be off of the origin. Let's graph y minus 2 quantity squared over 36 minus x plus 1 quantity squared over 49. Well, the first thing I notice about this hyperbola is that the y is first, so that tells me that our hyperbola is going to open in the y direction, up and down. We have parentheses, so we're going to use h and k to identify our center. Remember that h is always with x and k is always with y, so our center is going to be negative 1, 2. I am now going to plot my center and then draw in my rectangle. So my center is negative 1, 2. We're going to use A and B to draw our rectangle. So we're going to take the square root of the number under y and then go that many units up and down from the center, and then we'll take the square root of the number under the x, and then we'll go that many units on either side of the center in the x direction, side to side. So we're going 6 up and down and 7 left to right. So 6 up and down. And then 7 left to right. We'll use these 4 points to create our rectangle. And now we will draw in our asymptotes by extending the diagonals of this rectangle. Now we're ready to draw in our hyperbola. Our hyperbola, because y was first, opens up and down. Each branch is going to follow along the asymptotes we've created, and it's going to hit the box at the point we already have marked. These will be our vertices, and we'll label those shortly. And there we go, hyperbola in blue. Let's identify those vertices. Just counting over, we have one at -1, -4, and another one at -1, 8. Next, we want to identify our foci. We're using the equation c squared equals a squared plus b squared. C squared equals 36 plus 49. That's 85. So c is equal to the square root of 85. I would try to simplify this. It doesn't, so we'll leave it the square root of 85. This time, because our hyperbola is opening up and down, this c value gets added to the y coordinate of our center. Our foci will be at -1, 2 plus or minus the square root of 85. The last thing we need to do is identify the asymptotes. This takes a little bit more work since our center is off of the origin. We're actually going to have to write the equation of a line given 2 points. And the points I suggest you use is the center and then one of the corner points. So we could use slope formula to find the slope here, or you could just count. I'd be inclined to just count. I know the slope is positive because I'm going up, so my change in y is 1, 2, 3, 4, 6, and my change in x is 7. So I know that the slope here for this first one is positive 6/7. And now I'll choose the center and write the equation of my line. You can use point slope form or slope intercept form. I like to use point slope form. So y minus 2 equals 6/7 times x minus a -1. Y minus 2 equals 6/7 x plus 6/7. And then we'll add 2 to both sides and get y equals 6/7 x plus 20/7. And that's our first asymptote. Now we have to do the same thing to obtain our second asymptote. I'm going to use the center and one of the corner points on the other asymptote. Again, you could calculate the slope by using our slope formula for the 2 points, but I'm just going to count. This time we have a negative slope because we're going down, so we have -6 over +7. The second asymptote always has a slope that's just the opposite of the first one. And then I'm going to use the center again to write the equation of my asymptote. Y minus 2 equals -6/7 times x minus a -1. Y minus 2 equals -6/7 x minus 6/7. And then lastly, we'll add 2 to both sides. The equation of our second asymptote is y equals -6/7 x plus 8/7.